Good morning, I'm Dr. Huang. Today we are going to conduct experiments to verify Hess law. This is what we have. For each group, you will have a tree with the chemicals, graded cylinder, and some other things. Now I'm going to tell you one by one. Each group will have two solutions. One is hydrochloric acid. The label says the molarity is 1 molarity. For accurate calculation, the molarity should have more six figures. You can ask the lab manager to get the exact molarity, maybe 1.00 or something like that. The second solution is sodium hydroxide solution. The molarity is 1.0 molarity. Each group will also have a bottle of deionized water. There are 3 graded cylinders for different solutions or water. This is a graded cylinder for water measurement. The label says H2O. The lab manager color is so nice. She already put a label on the graded cylinder. So make sure when you use the graded cylinder, do not use it for other chemicals. For example, the label says H2O. Only use this graded cylinder for water. Do not use it for sodium hydroxide solution or hydrochloric acid solution. Okay, the second graded cylinder is for sodium hydroxide solution. The last graded cylinder is for hydrochloric acid solution. Now let's move on. Each group will be given 2 styrofoam cups. In this experiment, we do not call them styrofoam cups. We call them solution colorimeter. When we use them, we put them stacked on each other. The reason we use styrofoam cups because they are good heat insulators. When we do thermal experiments, we want to make sure all the heat is remain inside the colorimeter. However, when you look at this styrofoam cup, there is a wide opening on top of this to make sure no heat is escaped from the colorimeter. Each group is provided a cover. When you conduct experiment, after you put down all the solutions inside the cup, you need to put this cover on top of this cup. So this way, the heat is always inside. We can minimize the escaping of heat. To make sure the temperature inside is homogeneous, each group is offered a stir bar. When you take measurements of the volume of each solution or water, you have to make sure it is at the mark. It's hard to control the volume at exactly. Therefore, each group is provided these droppers. Whenever the volume is close to the volume you want, then you use these droppers. I'm going to demonstrate this when I try to get the volume of each of them. Now let's move to this side. Each group is provided a stand, a stirring plate, a clamp, a temperature probe, a LabQuest device. There are 2 different editions of the LabQuest device. What you can see here is LabQuest 3. You can read it here. Now it is off. I can turn this on by pressing the power button. Then you can see this screen. The other edition of the LabQuest device is LabQuest 2. As you can see here, LabQuest 2 is just a little smaller than LabQuest 3. For what I just introduced, this is for each group. If you go to the balance area, the electronic balance is shared by all the groups. And for all the groups, they share a bottle of sodium hydroxide solid. As you can see here, sodium hydroxide solid. There is a scoopler is provided for this part of the experiment. Are you ready for the experiment? I want to make sure you must be safe. Therefore, I'm going to demonstrate. I have to put on my lab coat, goggles, and gloves. Now I'm going to put them on. Okay, this is my lab coat. I bought this lab coat about 10 years ago. I'm getting a little larger, but I'm glad it still fit. Okay, and then I'm going to put on my goggles. Okay, make sure it's a tight fit. The last step I'm going to do is I'm going to put on the gloves. Oh, sorry. Okay, now I think we are really ready for the experiment. Before we start our experiment, we have to make sure the LabQuest device and the temperature probe is working properly. You do not want to spend 30 minutes to start the experiment. Then all in a sudden you realize that the LabQuest and the temperature probe is not working. To check the LabQuest and the temperature probe is working properly is very easy. First, let's take a look at this LabQuest device. Let's look at this side. There are different ports on this side. If you turn this LabQuest device, you can see there are other different kind of ports for the LabQuest device. And then let's look at the temperature probe. This is the connector for the temperature probe. If you try to insert the connector to the wrong port, it will not fit. It doesn't plug in. If you plug into the right port, you will hear a click sound. Okay, listen very carefully. Can you hear that? Now when I turn the LabQuest device to this side, you can see the temperature is 23.6 degrees Celsius. It does give you a reading. However, I'm not sure if the temperature probe is working properly. What I'm going to do is I'm going to use my hand to hold the temperature probe because my body temperature is higher than 23.1. If I use my hand to hold the temperature probe, the temperature reading should go up. If it does go up, that means it's working correctly. Now I'm using my hand to hold the temperature probe. Now let's look at this temperature reading here. It does rise. That means the LabQuest device and the temperature probe are working correctly. I think we're ready for the next part of the experiment. Each group has 2 members. You can divide the job. I'm playing 2 people now. First, I will play the first person. The first person is going to assemble everything. The second person will get the mass of sodium hydroxide and get the other part. Now let's look at the first part. This is the stand. I'm going to put on the clamp here with the stand. Because nobody wants to hold the temperature probe for the entire period. Therefore, we will use this clamp to hold the temperature probe. As you can see here, this is loose. So we have to make sure it's tight and hold here. What you can do is you will turn here. Now I think it's tight. Now let's set up the LabQuest device for data acquisition. If you look at this corner, this shows us the mode of data collection, the rate, and the duration. If you use your finger to touch here, from this screen, you can set up the data acquisition parameters. For the entire experiment, I estimate it will take about 15 to 20 minutes. Therefore, I will set up the duration to 20 minutes. This way, if I finish early, I can always stop before 20 minutes. Now it's minutes. Then I use my finger to touch here. I will type in the numbers, which is 20 minutes. I click done. Okay, the sampling rate should be 1 sample per second. That means 60 samples per minute. Let me change here. Okay, I think the LabQuest device is ready to use. Now I'm playing the second person. The second person will get 100 milliliter of water and get some sodium hydroxide solid. Okay, make sure you pick up the graded cylinder which labels water. Get your wash bottle with deionized water inside. Because we need about 100 milliliters of water, if I just squeeze, it will take too much time, as you can see here. What I'm going to do is I'm going to open the cap and then put this on the side. I'm going to dump the water inside. When it is close to 100, I'm going to stop here. What I'm going to do is I'm going to get a dropper. So then I have better control to make sure the total volume is 100 milliliters. Okay. Okay, with the goggles, I cannot see clearly. I'm going to take it off temporarily. When the bottom of the meniscus is at exactly the 100 milliliter mark, it will be 100.0 milliliter for this graded cylinder. It seems I need to add a little extra. Now I think it is 100.0 milliliter. When you take the reading, make sure your eyes are at the same level at the 100 milliliter mark. If you are below, it will not be correct. If you look down, it's wrong as well. The next step is, let me put this back. Now what I'm going to do is I'm going to start the data collection. I will put the temperature probe inside the gradient cylinder. And this part is ready. Now I'm going to get the sodium hydroxide solid. Let's go to the balance area with the styrofoam cups. Make sure you carry the cap with you, because sodium hydroxide is absorbing water very quickly. Okay, now let's go to the balance area. Okay, this is the electronic balance. When we use this electronic balance, first, we have to make sure the gas bubble here is centered. If you look at this carefully, there is a bubble inside here. And the bubble right now is centered. That indicates the balance is ready to be used. If you take the mass measurement, the mass is reliable. If it is not centered, you can adjust that to make sure it is centered. Now I'm going to show you how to adjust the location of the bubble. There are two dials for this electronic balance. One is on the left, you can see here. The other one is on the right, which you cannot see right now. I will make adjustment of the dial. I will turn the dial. You will pay attention to the location of the bubble. Say, when I turn the dial, if the bubble will move away from the center, then I'm going to move backwards. It will go back to the center. Okay, are you ready? So look at the bubble very carefully. Now I'm turning. You can see that the bubble actually is moving away from the center, right? Okay, now I'm going to move backwards. Turn the dial back. Now the bubble should move back to the center. Okay, so I think it is centered. Okay, when the bubble is centered, that means the electronic balance is placed on a perfect flat surface. That's a requirement for precise mass measurement. When we come to the electronic balance, the balance is ready to be used. What we're going to do is we make sure it is on. We can press this button. It gives us a reading. That means it's working correctly. Now what we're going to do is I'm going to open the side door and put my styrofoam cups with the cap on top of it. Close the side door. Press the center button. This will zero the reading. Now the reading is 0.0000 gram. When you do experiment, you may not have 4 decimals. This balance is the best balance we can have, but for the student labs, you may only have 3 decimals, like 0.000. Now let me open the side door and take out the cup with the cap. This is a scoopler. We're going to use the scoopler to get the sodium hydroxide solid into the cup. Okay, let me put this aside. Open the cap. As you can see here, the sodium hydroxide solid is actually in pellet format. I'm going to take out one pellet and put it in. Then I get to estimate how much this is and then decide what I do next. As you can see here, for one pellet of sodium hydroxide solid, it is 0.153 or 28. I need about 2 grams. I probably need like let's do the math, maybe less than 10. Less than 20. So let's try to put down 10 and say what will be the mass. The pellet has different sizes. If you put on a bigger one, you will expect the mass is higher. Let's say the mass we added here. 1.1740. Our goal is 2 grams. Therefore, we need to add more. From the reading, the mass of the sodium hydroxide solid is 2.1044 grams. I need to write down this number immediately in my notebook. I already get a data table ready before I enter the lab. All I need to do is I just write down the number, the mass of the sodium hydroxide solid, and the volume of the water. This is different than what I wrote, therefore I need to cross this out. Make sure you only put down one line. Don't scramble it. Then I put on the right mass. 2.1049 grams. As you can see here, my writing is pretty big. Therefore, when I design the table, I need to make sure I have enough space if this happens. Now we have the solid sodium hydroxide here, water here, and the LabQuest device. What we are going to do is we are going to start to collect data. If you look at here, there is a green button here. If you press, it will start data collection. Okay, now I'm going to hit this button now. Okay, you can see the temperature reading is here. It will plot here as well. Our goal is to record a flat line. Make sure the temperature is constant before we mix the water and the sodium hydroxide solid. We need to record about a minute or two. Let's be patient and wait for that. Here shows the time. Now it's a little over half a minute. I think the temperature reading is pretty constant. Let's wait long enough, then we can start to mix the water and sodium hydroxide solid. As you can see here, it's pretty flat. Now let's mix the two. Okay, as I just mentioned at the beginning of this experiment, I want to make sure the temperature inside is homogeneous. To make sure it is homogeneous, we need to stir the solution inside. Each group is provided with a stirring bar. I put this stirring bar inside the styrofoam cup. I'm going to put on top of this stirring plate. Now what I'm going to do is I'm going to adjust the position of the temperature probe. The left is the stirring dial. As you can hear some sound that indicate the stirring plate is working. Now I need to lower down my temperature probe. I do not want to put this too low. Then if it is too low, it will be struck by the stirring bar. I do not want to put this too high. If it's too high, it's not in the solution, it will not show the right reading. You can estimate like this way. So this is my final location of my clamp. Now I'm going to do that. You can adjust the stirring speed. Now let's look at the LabQuest device and look at the reading. You can see that the temperature is rising. If you want to see better, you can also scale the graph. What you do is you use your finger to touch here, graph, then auto scale once. You can see that the temperature is rising. We will wait until the temperature is constant again. Okay, the temperature is almost constant right now. Let's wait for another minute or two, make sure it does not rise again. I think we're good. This is the final temperature. This is the initial temperature. From this curve, you can see that you take out the temperature probe from the water, and then you put it in the mixture of water and sodium hydroxide solid. I think we're good. Once you're done, you press this red button. It will stop recording. Okay, then to here, we will turn off the stirring plate. Then we're good. Okay. Now let's dispose of waste we produced. What we do is we raise up this clamp. We bring this cup to the hood. There is a waste container inside the hood. We dump the waste into the waste container. Each class, not each group, is given a fission pole. What we do is, look at what happens. Okay, so the stirring bar is taken out. You can rinse it. Then dry it. This stirring bar will be used for experiment 2. After we dump the waste, we have to make sure this styrofoam cup is dry. You can use a paper towel, which is provided to you, to dry it. After you dry it, actually what you can do is you can just do something like this. This is dry. You just use it directly. Now let's start the second part of the experiment. We will get 50 milliliter of hydrochloric acid and 50 milliliter of sodium hydroxide solution. And this is hydrochloric acid. This is HCl, so this should go here. And this is sodium hydroxide solution, and this is NaOH. So we go here. Let's do them one by one. Okay, I'm going to open the cap. Okay, we need about 50 milliliters. When it is close to 50 milliliters, I'm going to stop and get a dropper, because I cannot see clearly with my safety goggles on, so I'm going to take it off temporarily. Actually, I'm thinking I'm too old, so I'm going to take off my glasses so I can see better. When the bottom of the meniscus is at the 50 milliliter mark, the volume of the solution will be 50.0 milliliters. Let's record this number in the notebook. Okay, for experiment 2, the volume of hydrochloric acid is 50.0 milliliters. Now let's get 50 milliliter of sodium hydroxide solution. This is the same procedure as you did. It should not be difficult. I will use my palm to face the labels. So this way, if there's any liquid coming out, it will not react with the label. It will be okay here. We stop when it is close to 50. Then we get a dropper to add to 50 milliliter mark. Okay, I think it is 50.0 milliliters of sodium hydroxide solution. Let me record the number. The volume of sodium hydroxide solution should be here. Now let's get the temperature measurement. Let's get the temperature probe. Take it off, make sure it is dry. There's no liquid there. First, let's put the temperature probe in the hydrochloric acid solution. Let's look at the lab quest. We need to hit this green button again to start the data collection. It asks us to what we should do. We will choose store. Now we can see the temperature is being displayed. The purpose of this part is we make sure we get the initial temperature of the hydrochloric acid solution. We need about a minute or two. If the temperature is constant, we're ready to get the temperature of sodium hydroxide solution. Now it's about half a minute. The temperature is constant. It should be constant. If you see the last digit is fluctuating, it's okay. Okay, I think the temperature is pretty stable. It's about 20.6, 20.7, 20.8. It is fluctuating. That's normal. It can be the electronic noise. Now let me put this down and take out the temperature probe from the hydrochloric acid solution. Don't knock it over. We had to dry it before we put into the sodium hydroxide solution. This is the sodium hydroxide solution. Now let's put this in. Let's put this here. And let's take the reading again. As we can see here, we can clearly see that we switched the temperature probe from one solution to the other. It will become stable again. Let's wait for a minute or two. If the temperature is constant, then we can mix the two solutions and record the temperature again. 20.8, 20.7. This is normal. $20.7, 20.8, 20.7. I think this is pretty good. We are ready to mix the two solutions. Okay, let's see. This is the styrofoam cup, which is our solution colorimeter. This is the cover. We need to put the stirring bar inside the styrofoam cup. When I turn on the stirring plate, the stirring bar will rotate. To demonstrate that, I'm going to put the stirring bar here. Let's see what happens if I turn on the stirring plate. No, it's nice, it's working. So let me turn this off and put the stirring bar inside the styrofoam cup and pour in the first solution, which is HCl. Make sure all the solutions is transferred inside. And then we take out the temperature probe and clamp here. Okay, it's stable. And then we mix them together. Put the cover on top, lower this down. Turn on the stirring plate. Then let's look at the temperatures. You can see that the temperature is rising very quickly. The second experiment is very, very fast, super fast. As you can see here, the temperature is almost constant. This is a solution reaction. Solution reactions are very, very fast. And then I want to check, make sure the stirring is working properly. No, I can see that. Turn this a little faster. Okay, let's see that the temperature is 27.0, 27.1, 27.0. It's fluctuating. That means it's almost constant right now. Let's wait for another 30 seconds. I think we will be done. And do you remember which part is for hydrochloric acid solution, which part is for sodium hydroxide solution? Whenever you prepare your report, you need to label them clearly. I think we get a almost perfect flat line right now. That means our experiment is over. Let me turn it off. And then let's turn off the stirring plate. Now I'm going to dispose the waste we just produced. Raise this up. And then I'm going to take this to the hood and then dump the waste we just produced. Now let's finish the third part and also the last part of this experiment. We will mix hydrochloric acid solution with sodium hydroxide solid. This is almost the same as the first part of the experiment, except that the first part used water to mix with sodium hydroxide solid. The last part used hydrochloric acid mixed with sodium hydroxide solid. Let's get started. First, let's get 100 milliliter of hydrochloric acid solution. Put into the hydrochloric acid graded cylinder. I think the volume is 100 milliliters. Let's put it back. And then let's put the hydrochloric acid solution here. Now let's move to the balance area to get about 2 grams of sodium hydroxide solid. And zero that. Okay, take it out. Oh, I did a very good job. It's very close. One more pellet. We will be good to go. Let me write down the mass of the sodium hydroxide solid in my notebook. Now let's go back to our station. Okay, let's continue. Let's take off the temperature probe and make sure it is dry. And insert the temperature probe in the hydrochloric acid solution. Let's look at the LabQuest device. To start our data collection, we click the green button here. It will ask us what we do for the previous data. Again, we will choose store. If we choose store, it will be saved in a different Excel sheet. That's what we want. Okay, as you can see here, it starts to show the temperature of the hydrochloric acid solution. Again, our purpose is to get a flat line for this part. We need about a minute or two. Now the temperature reading is 20.8. It should not change. Let's just wait. We get a flat line. We will be good for this part. $20.7, $20.8, $20.8, $20.7. This is normal. 20.8, 20.7, 20.8, 20.9, 20.8, 20.8. Now it is a minute. We get a pretty flat line. We're good to the next step. Okay, let's look at what we have here. We have our sodium hydroxide solid inside this styrofoam cup. What we do is we will put the stirring bar into the styrofoam cup. Put on the cover. Now let's take out the temperature probe. And clamp here. I think it's pretty stable. Now let's mix the solid with the solution. Okay, let's lower down the temperature probe. Make sure the temperature probe is inside the solution, but not to the bottom, because if it goes to the bottom, it will be struck by the stirring bar. You can open this temporarily and say if it's inside the solution. Yes, it is. So now let me turn on the stirring plate. You can hear some sound indicate it's stirring. Okay, now let's look at the LabQuest device. We can clearly see that the temperature is rising. We will not stop until we see a flat line again. The temperature is still rising. Still rising, 29.2, 29.3, 29.4, 0.5. This is not fluctuating, it's rising. A flat line, and then it's rising. The mixing is occurring here, and then it's rising. When the reaction is over, the temperature will stop rising. 31.0, still rising. 31.4, 0.5, 0.6. Just be patient. Okay, it's flattening out, but we will not stop until we really see a flat line. Right now, it is not flat enough. If you take this reading, it's still rising. 32.1, 32.2, 32.3. So we need to continue to wait. Point 3. If you look at this line, it's still rising, not flat enough. It doesn't take very long. It's still less than 6 minutes. This is a relative fast experiment. Let's wait another 30 seconds. I think it's pretty stable right now. 32.4, 32.3, 32.3. It's pretty stable now. Let's wait until 7 minutes. We will stop here. I think it is flat enough, so actually we can stop now. So what we do is we just hit this red button. Now it is stopped. I'm gonna stop the stirring plate. and dispose the waste. Now we are done for all the experiment. The next part is to export the data from the LabQuest to a USB drive or flash drive. Okay, let's export the data to a USB drive or flash drive. Make sure you bring a flash drive with you. If you don't, I will charge you $10 per minute. Oh no, you're my student, so I will be nice to you. Maybe let's reduce price to $1 per millisecond. Sorry, I'm joking. So let's look at the side. There are two USB ports. There are two USB ports for this LabQuest 3. Okay, what you do is, this is USB drive or flash drive. You can insert in here. Make sure it is in. Okay, now let's look at the screen. What you do next is you use your finger to touch file. Don't choose save, choose export. Then this will show what is in your USB drive or flash drive. If not, you just use your finger to press this icon. It will show that. If you use your finger to touch this area, you can put a name for this experiment. I can put this one for Hess law, H-E-S-S, Hess law. And then I can put on my last name, so to indicate this is my data. Okay, I will click done. Okay. Okay, I will click OK. Okay, sorry. It's not very sensitive. Oh, okay, it's working. Saving file. So to make sure the file is already saved, what you do, you click File again, go to Export. You go through that and then say, if you say the file name you just saved. Well, I do see that this says Hess-Lo Huang. Yeah, this is what I just saved. Okay. Okay. And then I'm gonna unplug and then put this into my computer to say if the file is there.